We just call it net zero in short. And it was a very, very exciting journey that started back in 2019. What I'm going to do first is just go over the agenda, and then I'll pass it on to Dan to take us through what the City of Toronto initiatives are all about. Then I'll take you through the project design, a very high level overview, as well as a brief project schedule of where the project is at right now. And then I'm going to go through the carbon study of the net zero energy and emissions for both operational carbon as well as embodied carbon. So Dan, I'll pass it on to you.
Thank you, Zina. Well, welcome everybody. So I will just be hopefully brief and leave Zina to do the bulk of the detail that everybody is interested in. But I wanted to do a little bit more introduction on pretty much, why and how Toronto is addressing climate change. Kind of why is, well, the picture kind of tells us everything, and we will be seeing more and more of the climate change related issues over the next decades. And so it kind of leaves us with kind of two things that we have to do. We have to do both mitigate event emissions and to be able to eliminate or avoid catastrophe that's heading our way, as well as we have to adapt to all the issues that we'll see over the next few decades that cannot be avoided anymore. So the next slide. So globally, through Paris Agreement, I'm sure everybody knows that the whole community will agree that we'll try to keep a global temperature increase under 2 degrees Celsius, as hopefully 1.5 will be preferable. Now, Toronto's reduction targets, we started with in 2015. I guess we had 80% reduction in emissions by 2050. Starting from the late last year, City Council decided that we should actually do much better, and we are now at net zero by 2040. Next slide. This shows kind of the model path to net zero, and there were a couple of options that were modeled. So obviously the first one typically is the worst case scenario, do nothing, which doesn't get us anywhere. They looked into what we already have planned, all the measures that were planned for the next few 2 decades, and the business as usual or business as planned scenario would bring us somewhere, but not nearly far enough to where we need to go. And really the only really target, it's a dark blue line that meets both 2030 emission reduction target and 2040 or 2050 target, is the net zero by 2040 kind of pathway. You also can see that that pathway doesn't really lead to zero, unfortunately. It's dependent on a decarbonization of electrical grid, and that could that may be handled by the province and the feds, but if not, then the city will have to do either carbon purchases or renewable energy certificates to get to the actual real net zero. Next slide. So there are numerous actions that will have to happen over the next 18 years, sorry. But they broadly can be, there are broadly 3 sectors that we have to focus on. It's renewable energy. In 2040, it should be unusual to see a house or a building without any solar PV on it, contrary to now. There should be wide use of renewable natural gas from waste, both solid waste and wastewater, and there will be wide use of energy storage. The sustainable transport really means electrification of transportation, as well as a large focus on active transportation, which means enabling biking and walking, at least for the short trips. And what we are going to spend all our presentation is on the low carbon buildings, and specifically we will focus on the new construction buildings, but as well, all existing buildings need to be retrofitted to net zero as well. And last is the grid decarbonization. So on the city policies, on the next slide, we'll see there are a number of policies that got stringent, more stringent and more detailed over years. And I just wanted to highlight the key policies from the last year. For the citywide, council adopted, as I mentioned before, Transform TO with really ambitious strategy to get to net zero by 2040. For the next two ones are really focusing on the city buildings, and we have Toronto Green Standard version 4. That standard, there is a separate standard for the city-owned new buildings, which now requires net zero emissions for all the city buildings, all city-owned buildings, starting next month, I guess, sorry, May 1st. And for the city-owned existing buildings, we have a plan as well that will bring us to net zero emissions by 2040 for all city properties. And just want to highlight a few examples of city measures that are focusing on city-owned buildings and properties. And just keeping in mind that city corporate wide emissions are 3% of the total. So we are a small part of the bigger picture. However, it's imperative for us to lead by example. And to do that, we committed to net zero buildings now, this starting May. Maybe Toronto Green Standard, everybody else will have to be net zero by near net zero in 2028. We were doing it 6 years early. But we found it through the North East Scarborough and the other buildings that are in design or construction that are doing net zero already, is that we expect around 5 to 7% additional investment required. However, the value in doing it net zero now is that we avoid much higher cost in retrofitting those buildings, and including the facility disruptions, closures, because those retrofits are not small, there are deep retrofits. And what we also found that currently, I guess, at least currently, the biggest barrier on the budgeting and costing is not net zero, not additional investment required to reach net zero, but the overall construction cost inflation that we are seeing, and it could be upwards of 25% higher than what was even 2 years ago. So that's much bigger problem than just reaching net zero. And there are a number of initiatives that we have on retrofitting city buildings, on the city fleets, including TTC on fleet, moving towards the electric buses, and solid waste is committed to completely eliminating any methane waste from both the green bin and the landfill, and utilizing them for renewable natural gas. So on the next slide. So going back to the existing new construction with Toronto Green Standard version 4, for city-owned buildings, we have, I wanted to just highlight two measures on emissions target. On stepping just a little bit back, on version 3, that was in fact until from 2018 to 22, all new city-owned buildings had to go through investigation that Zina are going to talk about for North East Scarborough one, in investigation to see if it's possible to reach net zero, and what is needed both in cost and measures that they need to implement. Now for the new Toronto Green Standard, we just made it mandatory. It's not anymore investigate and see, and if there is a budget, it's really a mandatory requirement that you must do it. On the energy target as well, you can see the progress of that we had. So under version 3 of Toronto Green Standard, all city properties need to be at least 25% better than the building code. Now they have to be at least 50% better than the building code. And in 3 years from now, we are really aiming to reach kind of a passive house standard equivalent targets. And on the embodied carbon, I just want to make sure, frankly, 2 years ago, that wasn't really a concern to us because we were for so many years we were focused on reducing the energy and carbon on from the operations. And now then when we actually started designing and constructing now net zero buildings, then everybody realized that, oh, now that operational carbon is solved, what about the building carbon in building materials and construction? So on the global CO2 emissions by sector, it's 11%. But that obviously, as we reduce the building operation piece of pie, that embodied carbon is going to be a major problem that we have to deal with over next time. And that Toronto Green Standard version 4 is starting to address that. And over time, we'll get more stringent requirements will be implemented. And just on the last slide, I just want to touch base on a little bit on the lessons learned. And it's no surprise to anybody here, but really in this pyramid, you have to start with reducing the energy loads through passive design. That's key for everything. Once you get the best envelope that you can, then we looked into heat pump systems or any heat recovery, any extremely efficient mechanical systems that further reduces the load. That allows us to actually be able to utilize renewable energy or other low carbon energy that's available to us at that site, one particular site, to offset that energy. A couple of things that we have learned as well is how to do this. Is that we have to, like in all city projects now, if you ever bid on any city projects for the new construction, you will see that the RFPs will specify that this is net zero emissions building, that they have some passive design principles, and some specify net zero energy goals as well. That may be aspirational depending on your particular location. But that's the goal that we should always aim for, that we should generate as much on-site renewable energy as the building uses. Again, with a asterisk there that it may not be possible for all locations. I think it's absolutely necessary to require air tightness testing. We need to know that the building can be designed to be best, but if it's not built to be net zero, or construction practice itself are lacking, then the building won't be operated as a net zero building. So that's absolutely crucial to have it. And with that as well, I listed here as optional, but I really highly recommend that, is to require third-party commissioning and M&V to be set up, because we must know that this building is built as designed, and we also need to have a plan in place how we're going to actually monitor and prove to everybody that this is a net zero building. And if possible, as again third party, it's required that the design meets the zero carbon standard by the Canadian Green Building Council. And with that, I will give it over to Zena to lead us through the details of the building itself.
Thanks. Just to comment on this last slide, in the case of North East Scarborough Community Centre, those two optional items that Dan just mentioned are actually integrated into the project. So the project is going for CaGBC Zero Carbon Standard, and we do have a commissioning authority on board with an MNV plan. So, so a little bit of history about this project. So you heard Dan mention the different version updates of the Toronto Green Standard. So when this project was awarded to the design team of Perkins and Will, Footprint, and Smith and Anderson, this was actually prior to even version 3 release in May of 2018. So there was no requirement of even carrying out net zero energy or emissions analysis whatsoever. But after seeing shortly after the project was awarded that that version 3 of the Toronto Green Standards requires a net zero emissions feasibility study, we saw it as an opportunity, and we started to collaborate together with the City of Toronto, trying to figure out, is there a potential to upgrade this project to a net zero community center, which would be at the time the first community center with an aquatic component to go for net zero emissions. And so we said, let's embark on the study and see how it goes. And we did. And the project was tendered and awarded recently, and it's still on track to be net zero carbon. So that's definitely a success story. So let's go over a little bit of a design overview. So this project is located at 8450 Shepherd Avenue East. It's in the Joyce Trimmer Park, if anybody's familiar with it. So it's got a lot of really unique site characteristics. So as you can see, there's Shepherd Avenue here, and the project is quite a bit set back. It was kind of a requirement. I think there's a fire hall here, and then this is all pertaining to that site as well. And so to fit the building, it had to be set back. The design was actually well underway by the time this project or this feasibility study was started. So there's definitely a lot of lessons learned. The earlier you do these kinds of feasibility studies, the better integration there is. And we're going to be very open and honest about some opportunities that may have been missed through this project and how they could have been improved. But we're really trying to feature this case study as more of a lessons learned and some of the success stories of, you know what, it's probably not too late to upgrade projects at the same time. So it's a little mix of both messages. So it's set to be complete in fall of 2024 or so. And if you take a look at it, it's kind of composed of 3 different strata. It's supposed to really reflect the nature of the site that's around it. There is a lot of natures and ravine and greenery around the site, and it's really picking up on some of the color schemes of what was found on that site. To give you an idea without going into details in terms of the major usages, so we've got a pool, we've also got a basketball court, a gym facility, as well as let me go into the right ones. Okay, so we've got the gym, you've seen the pool in the previous slide, and we've got multi-use spaces. A bit of inside renderings. I am going through this rather fast. I think CLF will provide a copy of the presentation if you feel like you want to go a little bit slower. It's just there's a lot of content obviously in this presentation and I'd love to get through. So we really took a whole life cycle approach. Embodied carbon wasn't necessarily part of that analysis initially. By the time we embarked on this project, much of the design was actually completed. The opportunities here was to try to electrify the building and to integrate energy reductions and try to get this to a net zero energy and emissions building. But partway through, we collectively realized that we should probably take a look at the embodied carbon as well. I think that CaGBC Zero Carbon Building is, a major part of the reason as to why we did take a look at the embodied carbon and try to introduce reductions. So we were very thankful for the existence of that system. So embodied carbon, for those who don't know, is really the upfront carbon associated with the building materials. As Dan mentioned, most of the focus in the past has been around operational carbon. But as we get into higher performing buildings and net zero carbon buildings, then really the balance of the carbon that's remaining is the embodied carbon, and that's why it really needs to be of strong focus, equal and parallel to the focus that we're giving operational carbon as well. So this is more of a measures summary matrix of what we took a look at during the feasibility study. There were more options that we did take a look at. Some of them weren't very viable or not applicable due to the stage of the project at the time in terms of design, and unfortunately, we wouldn't have been able to integrate a certain number of measures at that stage. But this is really what we went back to the city and discussed as to what we would like to analyze, and we collaborated with the city as to what additional measures would they like us to look into, and really tried to focus in on the total energy usage, the greenhouse gas intensity, as well as the energy savings. At the time, you heard earlier that the future versions of Toronto Green Standards are just going to require to have net zero emissions buildings. But in this particular case, we also look at sort of payback periods at 20 years, but also at 30 years, because there were no set requirements as to what this building needed to be at the time of the study. So we broke it up into 3 categories. Passive design elements. So we took a look at envelope improvements, shading, air tightness improvements. We took a look at varying active systems and also renewable energy production potential on the site, and tried to maximize these opportunities, and introduction of newer type of technologies that typically are ruled out due to really high costs or difficulty in design integration. And so there is a bit of a success story on this project that we'll go over. So our design options summary. So essentially, if you took a look at just a Toronto Green Standard compliant based design, which was equivalent to the Toronto Green Standard version 3, tier 2, the total energy use intensity starting out on this project was about 306 kilowatt hours per square meter. The greenhouse gas intensity was roughly at 37. And if we are going for net zero energy and emissions, then obviously the total energy use intensity would be 0, and the greenhouse gas intensity would be 0. And that's what energy and net zero energy and emissions is. And we took a look at optimization of the design in terms of a 20-year payback as well as a 30-year payback, and what does that do in terms of which technologies end up being integrated and what kind of reductions are we seeing on each. So in terms of a breakdown, I thought, I've attended a lot of presentations, and sometimes I just felt like it was lacking a little bit of meat. I felt like it needed a little bit more substance, things that people can walk away. So what I wanted to offer is sort of a little bit of a highlight of cost premiums. What were some of the challenges and opportunities that we looked at on this project? So in terms of a cost premium over a typical Toronto Green Standards, we found that it's in the range of 8 to 12%. That's a little bit consistent with a few more projects that we've done since then. In terms of net zero energy strategy breakdown, so when we look at enhanced envelope, it was what the enhanced building envelope, which I'll provide details for a little bit later, it offered a 6.8% saving in terms of energy. Air source heat pumps offered 30.4. Heat recovery offered 1.6. Drain heat recovery 8.2. So those are like more of the notable chunks in terms of energy savings. Now keep in mind that the first move on this, or the first change for this feasibility study, was to electrify the building. So disconnect from unclean fuel sources, which in this particular case and in most cases is natural gas. So once we've electrified, now we're trying to look at energy savings, of course. So for renewable energy, we looked at PV thermal roof panels. They introduced 23% energy, and bifacial PV panels, canopies, and they're actually within the parking spaces. And we introduced 1,300 square meters of PV that is mounted on the ground along an access way at the north side, and building integrated PV on the south facade, which represents about 2%. And one really important thing to note about this type of facility is that it is very energy intensive due to the process related more specifically to the aquatic component of a community center. So that's a whole challenge on its own, just having facilities with aquatic components. So it did require a lot of creativity in terms of trying to locate opportunities on the site for more renewable energy, and where else can we squeeze in more PV but yet have a very nice looking site because people can see it obviously, and they need to be able to visit the site and not be thrown back by all the PV that was happening on the site. So to take a look at the enhanced envelope, again, a little bit more meat to this presentation, but in terms of capital construction costs, we're kind of looking at 8 to 10% more than a conventional wall, roof, and glazing costs on this particular project. So of that 8 to 10%, 20% of that 8 to 10% had to do with the wall improvements. This project went for an R25 effective R value, and we took a look at sort of the biggest bang for the buck in terms of optimizing what is the most ideal insulation level for the walls. We did the same for the roof improvements. So in terms of do we go R30, R40, R50? In this particular case, we are at R55, and it is introduce 15% premium of that 8 to 10%. Or I should say it represents 15% of that 8 to 10% premium. Triple glazing was a huge chunk. So that one was 63% of the premium of that 8 to 10. And the air tightness improvements was about 2% of the premium. And it's really related to additional design detailing, for example, but also the construction related air tightness testing, for example, and even additional work related to commissioning authority in terms of building envelope. So the energy saving of the enhanced envelope was 6.8%. And of that 6.8%, 0.3 was due to the wall improvements of R25, 0.3 was due to the roof improvements. Triple glazing offered 2.6 of that 6.8, and the air tightness represented the most, which is the 3.6 of that 6.8. So active systems, we did analyze different active systems. What the project ended up with is air source heat pumps. We did take a look at geothermal, and fortunately, due to the makeup of the ground, it was a hefty premium to actually go geothermal, even though, everybody was heavily invested in both geothermal or air source heat pumps, so it could have really gone either way. Geothermal does tend to introduce a little bit more of a resiliency aspect, just because it is a little bit less finicky than air source heat pumps, for example, in extreme cold weather, as well as longer lasting. So the capital cost was with the air source heat pumps, the capital cost was at about 1.3 million in terms of what was estimated, and the energy savings that were introduced were about 30.4%, which were quite substantial. So in terms of the heat recovery efficiency, so the capital cost was about 320,000. The energy savings was about 1.6. These numbers are very subjective. Some people might say the capital cost is quite expensive, for example, the energy savings. But I think that with net zero buildings, of course, you're always reaching for the lowest hanging fruits first. But eventually that last bit of savings that you're trying to get to net zero energy and emissions is usually the most expensive. So you start looking at the incremental costs of associated with 0.3 energy reductions, for example. And so it does end up kind of incrementally increasing the cost of projects. Obviously, there's a lot of I didn't want to get too detailed into each of these systems. If anybody's really interested in just having a conversation, you're welcome to reach out directly to either of us, and we're happy to go into more of the details of some of this study. So in terms of drain heat recovery, the capital cost was about 50,000. However, the energy savings was about 8.2. And what we're recovering is basically transferring heat from the outgoing warm pool drainage water and trying to temper the domestic cold water that's filling up the pool. So to take a look at renewable energy, if you take a look at the site here, there's I'll kind of go over. There's obviously PVT on the roof. There's also photovoltaics that were introduced on mounting structures above the parking lots. We also introduced PV that is along this side as well. And so the capital cost of the PVT on the roof in general is somewhere between 450 and 600,000 if you're budgeting. And the energy saving targets, or I should say the energy produced from just PVT on this rooftop was about 23%. It used about 460 PVT panels. In this particular case, you know, photovoltaic thermal hybrid panels versus PV, I think it really does depend on the type of project that you have. In our particular case, we have a pool, so PVT panels in our analysis ended up making more sense. And that's what we used. In other projects where they may not have a pool component, PV might end up being the choice. So in terms of how much energy it's actually generating, so in electricity, I've got it noted here. In terms of thermal generation, so it's dual, obviously, because it is PVT. So in terms of bifacial PV parking panels, we wanted to, you know, we've got limited site space. We wanted to maximize how much renewable energy we're able to produce. So bifacial panels, you know, they receive the sun's energy on the front face, but they also receive the reflection of the sun from surfaces from the bottom side and produce even more. And so those are actually mounted above the parking structures. So what we have, so they're going to produce about 23% of annual generation, and there's about 820 panels covering 1,640 square meters. There's also PV on the north side edge of the site, and it is 600 panels, and the coverage is about 1,200 square meters. So building integrated PV introduced on the south facade, about $330,000 worth of it, and it's going to be about 2% of the total energy generation, and it's 152 panels total. In terms of air tightness enhancements, specifically, we went for leakage testing to a max of 1 liter per square meter at 75 pascals. And we introduced, we do have a commissioning authority on board who's, for the envelope, who's analyzing sort of some of the measures that are integrated, as well as overseeing the process during construction. We do have a third-party verifier as part of the TGS as well, and we are going to engage air tightness testing during construction. So we did explore it, but, you know, I just wanted to give this as an example of something that was explored that's, you know, thinking outside the box. It did introduce 5% energy savings at 200,000. You know, that's actually a pretty good deal for a net zero building. However, it unfortunately is just logistically was a challenge. I think it's great to think outside the box, but I think that there's going to be some behavioral changes for something like this to be accommodated. I can foresee it being in the future in future facilities, but I think there's going to be additional training, additional safety measures. There were some concerns of, you know, after the pool covers, after the facility closes and pool covers are put in, then, you know, if somebody accidentally falls in under the cover and you can't see them, you know, that's a safety concern. And there's also the logistics of who's going to operate them. So that's why we decided fully automated, whereas something manual could have been much, much cheaper. So I'm going to go through the embodied carbon as well. Just as a heads up, this study again was, there was a bit of a limitation as to how much embodied carbon reductions we could achieve, and had it been done much earlier, I think we would have had a little bit more influence in terms of what reductions we could have introduced to the cladding, for example. So we were able to introduce the reductions from the structure side. We could have explored more structural options had this been done earlier, such as mass timber, for example. At this point, the structure was set, the envelope was set, but we tried to see what kind of tweaking that we can actually do, and hopefully it helps as a lesson learned for yourself. So, as Dan mentioned at the very beginning, is why are we looking at this? Because historically we've been focusing on operational carbon and ignored embodied carbon, and it's just always been there. But as soon as you get into net zero energy and emissions building, really, that's the only chunk that's left. So if we want to be able to even put a dent in that chunk, we need to give it just as much attention. So what we decided to study back then, because the study started in 2019, what we know today is far better than what we knew obviously back then. And I think there are additional layered elements that we would be introducing into future projects. But I wanted to share what we did in the last 2 years as the project just got tendered, it just got awarded, and it's now under construction. So we focused a little bit more on the structural and architectural. We are starting to get more into the interiors. Although it's not a requirement at this point under the CaGBC, it's only optional to get into interior finishes. So here are the results. So the total project reduction is 24% over baseline. And the baseline really was the very first, what we chose to do it is kind of do it properly, which is the very first design that we put together for this Perkins and Will project of when we first started versus what improvements were we able to achieve when we started using or zooming in on it. So we wanted to be honest about it in terms of building envelope. Unfortunately, we did not touch that. It was a little bit too late to impact the study, though I will give you a little bit of ideas of what could have been done differently. So what we focused on is the concrete. So we were able to introduce, so we set we took a look at different concrete mix designs, set the global warming, max global warming potential. We actually integrated into the project specifications at the time of tender. It did engage an industry discussion amongst different parties. I think this was potentially the first, if anybody knows of another, please reach out to me and let me know, that introduced max global warming, first project that introduced max global warming GWP for concrete into the specifications. So in terms of the results, as you can see, most of it really is to do with concrete and some to do with the rebar. So if we take a look at, we tried to do a bit of a comparison. So where we started was about 526 kilograms of CO2 equivalents per square meter. Then we introduced a 24% reduction. We took a look at a little bit more of typical community centers. And so our baseline, which is our very first version of our project, was already better than sort of the typical average community centers, the data that we had. So that was good to begin with. And then we introduced an additional 24% on top. And why did concrete make such a difference? Well, if you take a look at concrete by weight, most of it is aggregate, lots of sand. So this is kind of proportionally what goes into concrete in terms of, cement's not that much, SCMs are not that much, but when you take a look at how it's split, there we go, sorry, it's a bit out of order, but when you take a look at how it's split in terms of the amount of embodied carbon, you could see that the biggest chunk of it is to do with cement, and that's why we focus on cement first. And the different strategies are, let's see if I can go back, apologies that it's slightly out of order, but if you kind of reduce the cement content by just 10% and maybe even increase the aggregate size in areas that are not so visible, because as soon as you increase aggregate, some design teams don't like that too much, because if you like to have exposed concrete, then it becomes a bit of a challenge to smooth the concrete and have it exposed. So I think you can strategically do that in terms of footings and foundations, for example, where it's not exposed. So in terms of, and then you can also substitute cement for Portland limestone cement. And that's how you can introduce embodied carbon reductions. So we found that there's no real increase in cost to do that, no real impact on schedule. It's there's ample in the industry, but there's a potential that not all plants have it. That's kind of the intel that we heard. We're learning about it now that the first project is under construction, so we'll be sure to come back and report. In terms of structural steel, what have we learned? Well, if you use an electric arc furnace, obviously your source of energy is electricity versus a basic oxygen furnace, where most of the time your source is natural gas, then you're able to do several things. Number one is an electric arc furnace can receive higher recycled content, which can really reduce your overall embodied carbon, whereas the basic or BOF will, you can only introduce a maximum of 25% recycled content. So I think that's one important factor. We're in the middle of researching and working with different construction teams and the industry, trying to figure out how many electric arc furnaces are there. So if we all jump up and we say we only want EAF, is that going to impact our schedules or even costs? So we're in the process of that research. We're still trying to figure it out, but this is where we are right now. Now that we've quantified embodied carbon, so at the time, once we quantified it, so based on the 2020 rates, to offset it was between 9 to 12,000. We've since had more carbon offset quotes in the past year, especially more recently this year, and we know that the market is very volatile and the cost has actually increased quite a bit. So something to note, the earlier, I guess you try to reduce it at the source. I think that's always a priority. Try to introduce your reductions through design always, and then that way you don't have to deal with offset volatility. So what are some of the lessons learned and next steps? Well, we're going to be updating our model now that we're entering construction. We're going to be working with Aquacon and the construction teams to try to figure out, well, can we further reduce embodied carbon through construction and then update our embodied carbon modeling. We're going to build a baseline a little bit better, so we can sort of analyze, what other materials could we have used so that we can formulate our lessons learned in terms of building envelope, and based on that, kind of determine what the lessons learned would be. Sorry, there's a little bit of flashing, so I only have one last element. So this is a general facade study that we did after this project, and it was just to analyze different types of facades, sort of take a small area, assume that all the, so this is just cladding only, all the backup would be the same, and we tried to do an analysis to kind of feed into the selection process on our future projects. And this kind of gives you an idea that, brick is not so great. Concrete panel is here, and ACM is here. So it's not to say avoid brick entirely, but I think once you start kind of quantifying your overall embodied carbon, then you start to set maximums and start to make decisions on where to spend a little bit more of that carbon and save a little bit more carbon in other areas. So I think that would be my approach. You want to look at aesthetics, you want to consider durability, etc. So lots of things to consider. So this just becomes another layer of consideration for design teams and for client teams to consider. So this is actually my very last slide that was out of order, but that brings us to the end of the presentation. I know, Michael, you were going to pay attention to some of the questions that are in the chat just because I can't see them myself. So I was wondering if we got any good questions out there.
Yeah, absolutely. Thank you, Zena and Dan, for that presentation. That was awesome. We do have a few questions that have come in. So your first question is actually a compliment to the PV approach for the site. So kudos to the team. But our first question is, do the capital costs of the PV include any upgrades to the structure, the roof penetration details, or any additional subgrade work?
Sorry, can you say that one more time?
Sure, yes. So it's a question about the capital costs associated with solar PV. Okay. And whether or not they include upgrades to structure to support PV, the roof penetration details, or any additional subgrade work.
No, it's literally, aside from the mounting structure to the roof, the substructure in terms of the structural, additional structural support going into the building, no, it's just this sort of the superstructure, the mounting framework that is associated with the PV.
Yeah, and I just want to add that this project, before we started net zero path, was would meet the green roof bylaw, which so it was designed for that. So the roof structure is already was kind of the cost for roof structure was already in there because green roofs would be much well, heavier than the solar PV, the ballasted solar PV system. So from that point of view, that's why we don't really have any additional structural reinforcement that we need for solar. Now on the carport side, obviously the structure itself of the solar PV carport, it requires you to use, I guess in this case will be steel, but that's part of the overall system.
Great.
Yeah.
Thank you. The next question is around, well, a group of questions are around carbon offsets. So where were the carbon offsets purchased or planned to be purchased from? And how selective were you with choosing offsets? And are they verified by third parties?
They have not been purchased yet. This was simply a quote just to kind of give an idea of where it was. And we know that it's actually fairly more expensive right now to purchase based on some of the recent quotes that we had for other projects. So I think that quote definitely needs to be updated. And the other element is, do you kind of purchase Canadian blend versus American blend? And that's sort of been an age-old argument for a while now. Is some people truly believe that we need to support the Canadian market and we should be purchasing them in Canada, but some others believe that supporting, climate change is a international issue. So wherever you want to support additional projects around the world, you should be able to. So if we're able to do it more efficiently somewhere else, and it's a better climate zone, and you can get more solar energy in a different zone, then that's where we should be directing our support. So it's still to be discussed. I think it's something that we need to talk to the City of Toronto. But Dan, you might have some more thoughts about that.
Yeah. Well, in general, I mean, this building, we will aim to have the zero carbon standard, the CaGBC standard, and the performance one. We are right now, because it's not built yet, we are going for the design stage of the design certification that Zena is leading. But once the building is constructed, that's when we need to purchase carbon offsets to offset the embodied carbon, and if there is any other remaining carbon left from the operations to meet the operational the performance side of the zero carbon standard. So CaGBC has we will follow their requirements pretty much on the carbon offset purchases, and they will be third party verified and very stringent requirements as far as I understand.
Great, thank you. All right, another question has come in. So if you could have started the building design from the start as a net zero emissions building, what would you have done differently than what's there right now? And would those early stage decisions have lowered the price premium on making the building net zero energy?
I think probably 90% of the exploration that we did probably would have been the same upfront. I think where things would have opened, there just would have been a little bit more opportunity upfront before the design had started to lower operational carbon, because then the stacking might have been different, the massing might have been different. There are certain things that got set very early on in the project that we weren't allowed to touch anymore. So maybe we would have had a little bit more less challenges in terms of mechanical space allocations, different technologies. I know we were looking at different, like biomass furnace, for example, but that's not possible because the building was set. So I think most of what we did that did end up getting integrated probably happened up front, so there wasn't too much impact on that. We just could have looked at more. We would have also looked at embodied carbon a lot deeper. What we I mean, what we found out through the study and things that we could have gone back and changed, they were already set as well. So.
Yeah, and I would agree with that. I mean, for the projects that we studied later that required net zero emissions buildings from the RFP stage right away for the architects and design team, we saw that it's just a smoother way of like with North East Scarborough, we had to go back. I mean, obviously, the design team had to go back and we tried to figure out what of the measures they installed or investigate could actually be based on the type of design. When you start right away, is one of the first things in schematic design, the flexibility is just much bigger. And that allows us to explore deeper than we were able to do here. We were much more limited with this first one. But that's the lesson learned.
Great. All right. Next, there is a number of questions in the chat. I don't think we're going to be able to get through all of them. So I do encourage anyone here to send an email to Zena or Dan after the presentation. But the next question is around achieving embodied carbon reduction in concrete. So was the use of GUL the only strategy?
It was one of the strategies. I think we looked at different things, trying to lower the cement use as much as possible, and SCMs, aggregate size, GUL, as well as looking at max GWP. So every trick we know about concrete, we tried to do for sure. There's probably additional premiums that you could pay for even better concrete, which is a bit of a discussion that needs to be had with clients of, do you want to make that investment? Because what we're trying to do now is to look at things in terms of good, better, best, and come up with a selection, a menu of options when it comes to operational carbon, but also embodied carbon, and work through with our clients to try to figure out how to get the max embodied carbon and operational carbon reductions within the set budget. So.
Great, thanks. The next and possibly final question is for you, Dayan. So would you be able to speak to how these targets have affected operational costs? Is there additional training for asset management staff at the city?
Well, yes. I mean, obviously, these buildings will be different than the standard, and the equipment in them, in heat pumps, may be something that building operators have not been experienced with. So there will be a lot more over the next few years. And it's not just for this building, but overall city, as we're retrofitting in existing buildings, we kind of face with the same thing. So we have to make sure that building operations staff is able to efficiently to maintain that level of efficiency that it's intended with this design. And so, yeah, so there will be additional training whenever the staffing is. There will be additional requirements on building operators, as well as that's why we talked about a little bit about monitoring verification. All these buildings have to have a tools already built in that we are actually able to monitor what's happening in the building, so that the building operators will be able to react if something is not going as it should be. That's another thing that overall we are facing is that we sometimes have the buildings that the operators there, it's kind of almost everything's manual, unfortunately, especially some older buildings. So it's it's hard to track. So that's the overall, both culture change, training, level of skills have to be improved. And it's a work in progress.
Awesome. All right. That's all we have time for today. So again, a huge thank you to our speakers. That was a great presentation. It will be available online. So thank you to everyone who joined us today, and look out for an email with a link to this webinar recording. All right. Have a great day, everyone. Thank you all.
Thank you.
Thanks.